Hi educators, I'm excited to share another awesome Patchr lesson with you, and this one is called Click Clack Backpack, and it's for the Makey Makey. So in the Click Clack Backpack lesson, we are challenged to create a printed circuit board or PCB that interfaces with the hugely engaging microcontroller, the Makey Makey. The Makey Makey essentially allows you to turn anything into a button. This could be a keyboard or input device for your computer, and with the addition of a PCB backpack designed in this lesson, students will gain greater understandings of real-world hardware design as they create their own unique prototype solutions. As always, there are endless possibilities with what you and your students can create, but through Patchr's unique design interface and instructional resources, students of any learning level can find success. Let's get started. After launching the Click Clack Backpack lesson through Patchr.io, we are guided through the fundamentals of how the circuit actually works by creating header connections that interface with the existing ports on a Makey Makey. We also look at the components that we will need as we design our printed circuit boards, as well as learn more about these components and how they can be wired together. As always, we're guided through the stages of this lesson by the Patchr teacher assistant known as Squidly. Squidly just keeps us on track, encourages us to keep going, and lets us know when we may have run into a problem with our designs. For the PCB board, you are provided with the sample shape that you're able to use throughout the lesson, but you can also draw your own board right in the Patchr Design Studio, or even upload a vector outline in SVG format that can act as your board shape. These types of shapes and board designs can be created in a lot of different programs that are suitable for students of all levels like Tinkercad, Google Drawings, or Inkscape. So it's up to the educator to choose the specific constraints for the design challenge, but we think it's an awesome extension to challenge students to create their own unique board shapes as they develop their prototype solutions. In the next stage of the lesson, we are guided through placing our components onto our PCB board. For the Click Clack Backpack lesson, this includes key components to make the circuit function properly, like our mechanical switches, an LED, as well as the header sockets, which will interface with our Makey Makey. What these components do and how they work are described in much greater detail throughout the lesson and the provided schematic diagrams, as well as in the Patchr Learning Library, which can be referenced right from the design interface. As we lay out our board, a ghosted image helps us ensure that the components aren't too close to the edge of our board or overlapping, as this could cause potential problems in the manufacturing stages. While this tool is there to help students who might be unfamiliar with PCB design find success, they do not need to use this, as students have the ability to design and lay out their board however they see fit. And don't worry, Squidly always checks our progress and will let us know if we made any mistakes. This even goes for custom PCB board shapes as well. We then need to create the circuit by routing the paths between the different components using the tracing tool. The guidelines can be used to ensure that we find success in this crucial stage of the design process. But there's usually more than one correct way to route a path. Again, students are challenged to design unique circuit boards based on their own shapes and innovative designs. Lastly, we have the chance to customize our board through the unique graphics and designs in our silkscreen layer. Students can add their names or the title of the project, or even a personalized design to enhance their PCB creations. Once done, we finish our boards and send it to fabrication. You will receive your custom PCBs from Patchr in a kit that includes everything you need to assemble your circuit. This also includes assembly instructions which walk students through each step of the process. To assemble our backpacks, we need to solder the components together. Soldering is the process of joining components together using a filler metal that we call solder. Now, we use solder to create a lot of things, but most often electronic circuits and electronic components. Soldering is a really important skill to learn if we want to be able to create our own custom electronics, and students will gain ability in soldering throughout this learning experience. For students who are entirely new to soldering, we recommend checking out our Learn to Solder resource guide, as well as our Introduction Design Challenge, while also referencing the assembly guide provided with each Click Clack Backpack lesson. As we assemble our backpack circuit, there are a few strategies that can be used to assist in the assembly process. For the tactile switches, we must ensure that the connection pins align with the circuit paths. We can see that 2 of the holes have paths running to them and are slightly bigger in size. These are the ones that we must solder our switches to. Polar components, such as our LED, have a positive and negative connection, and if we do not wire these types of components correctly onto our PCB board, the current is unable to flow through them. When installing the LED, we can align the negative connection or shorter leg with the square pad of our PCB. Lastly, we find that the easiest way to ensure proper alignment for the header connections is by installing the header pins in the Makey Makey first, then laying our PCBs over these pins as we solder them onto our board. Once assembled, we can test out our circuits. The Makey Makey works great on all devices with a USB port. Simply plug a Makey Makey into a computer and click away. The keys on the backpack will send the signal for W, A, S, and D by default, but this can be changed through Makey Makey's remapping program. Pretty cool, right? But the lesson doesn't need to stop there. There are endless possibilities for this project as students are not only challenged to create custom circuit boards, but also prototypes and hardware solutions around them. The backpack allows us to leave the typical constraints of a Makey Makey project behind as we incorporate various materials, rapid prototyping techniques, and computer programming challenges to create unique prototype solutions with limitless possibilities. We love to integrate coding, computer-aided design, 3D printing, and arts and crafts to increase the aesthetics and ergonomics in our solution, and we often find that this creates greater engagement and problem solving for students of all levels too. Visit us at patchr.io and start creating your own custom electronics today.